My name is Carly McFarland. I'm in Chem 110 in Section 9. This is Experiment 6, Determination of Citric Acid in Lemon Juice. The balanced chemical equation for the neutralization reaction performed involved using citric acid aqueous plus 3 NaOH. This yields sodium citrate plus 3 H2O, or water. So here we have citric acid plus sodium hydroxide yields sodium citrate plus water. In the Foundations of Chemistry Laboratory Manual, on page 46, it shows Table 1, the determination of the concentration of acid in lemon juice samples. Also mentioned, I wrote the molarity of lemon juice, which was 0.0813 molarity. Using the experimental sodium hydroxide titrant volume, which we discovered on Table 1, the experimental volume was 18.9 milliliters. From here, we have to change milliliters to liters, divide by 1,000.
Don't forget labels.
So because the molarity of the NaOH was 0.0813, we can determine that there is 0.0813 moles per 1 liter of NaOH, sodium hydroxide. If we look back to our balanced equation, we know that there are 3 moles of sodium hydroxide for every 1 mole of citric acid. After doing this equation, we can determine that there are 5.122 times 10 to the negative 4th moles of C3H5O COOH 3, or citric acid. Now, in order to find the molarity of the citric acid, we would have to divide that by the starting volume of juice sample. From the table, we saw that the volume of the juice sample was 2 milliliters. The correct equation for molarity is moles over liters. Since we cannot use milliliters, we have to divide 2 by 1,000. This is 0.002 liters. We can determine that the molarity of citric acid is 0.256 molar. Done. After doing some outside work, the citric acid concentrations for trial 1, 2, and 3 are shown here on this table. Trial 1 had a molarity of 0.256, trial 2 a molarity of 0.245, and trial 3 a molarity of 0.247. To find the average of these, we add them all up and we divide it by 3. So if we add all of those up, it comes out to 0.748 molarity, and we divide that by 3, and that equals 0.249 molarity, and this gives us our average for the citric acid concentration. In the laboratory manual, it has Table 2 and Table 3, which shows the comparison of the pH of lemon juice before and the pH of lemon juice after titration. Before titration, the lemon juice pH was roughly around 2.55 to 2.57. After titration, the pH of lemon juice went between 9.6 and 10.08. So as you can tell, after the titration, the pH goes up so that there's a base present. Looking at pH, acids have a lot of hydrogen ions, and bases have a lot of hydroxide ions. When you add hydroxide to the amount of hydrogen ions, it goes down. In the balanced equation, because we added a base to the acid, it caused the hydrogen ions to go down, making the solution more basic. Lemon juice is a weak acid, and sodium hydroxide is a strong base. When you add a strong base to a weak acid, the pH tends to go up to make the solution become more basic. In this experiment, we used Chemistry 110 Foundations of Chemistry Laboratory Manual by the Department of Chemistry and Biochemistry at the University of Mount Union. It was written by Dr. Booth, Dr. Jean, Ms. Santoro, Mrs. Saltis, and Ms. Schaub.